Welcome back. This is video 3 in our series on quantitative chemistry for Leaving Cert Chemistry. And in this video, you are going to need a periodic table and a calculator. Okay, so you're going to need those two things for sure. And a quick reminder, in the first video, we learned how to calculate something called the relative formula mass, or MR. And in the second video, we learned about the mole number. So what was the mole number now? You should be able to recall that number. That's a number you're going to have to know. So on 3, I want you to speak your answer to the screen. What is the mole number? On 3, 1, 2, 3. Okay, I'm hoping he said 6.02 by 10 to the power of 23. There's another name that we know this number by. What is the other name that we know this number by? Again, speak your answer to the screen now. 1, 2, 3. Okay, I'm hoping that you said Avogadro's number. So this is named after Amadeo Avogadro, who was the person who discovered it, that we have this number 6.02 by 10 to the power of 23. And I explained to you that that number is really, really important to chemists. Today, I'm going to try and explain where it comes from and why it's important. Now, please listen while I explain. You don't need to write everything down. There are some things I'm going to ask you to write down, but wait until I do. So imagine that we have a beaker, okay, and we put it on a mass balance. So a mass balance. Now you know what a mass balance looks like. It's for measuring mass. It has a digital screen that gives us a reading in grams. And many of you might have one at home for like cooking, or you should have used them in a science lab at some stage. Now the beaker is currently empty, so the reading is 0.0 grams. There's nothing in the beaker. Now imagine that I take an atom of lithium. Now an atom of lithium is incredibly, incredibly tiny. So I'm going to draw it here as a little speck, but it's really important to note that an atom is so much smaller than that little speck there. Not sure if you can even see that speck, but an atom is even smaller than that. They're incredibly, incredibly tiny. We can't see it with a microscope. It takes even our most incredibly powerful and sophisticated equipment just to find out where atoms are and what they're doing. So one atom, we're never going to be able to see it, but I'm going to have to show you what I'm talking about. So I'm going to draw them as dots, okay? But they are massively blown up. So imagine taking one atom of lithium and I put it into the beaker. So in it goes. Now, obviously, nothing's going to happen. It's still going to say 0 because the atom is way, way, way too tiny for the balance to pick it up because the atom is really, really small. Okay, so I add another one, still nothing. So there's 2 atoms, still no mass. And another, still nothing. And hundreds, nothing. Thousands, hundreds of thousands, still nothing. Until eventually, this number is going to start creeping up. But I've literally added millions of atoms before this happens. Because atoms are so tiny, I need so many, but eventually it will go up. So I've added a million, millions and millions and millions. Sorry, not 1 million, millions and millions. So eventually the number goes up. Say it's at 1 gram, and I'm adding millions and millions and millions more, and it goes up to 2 grams. Millions more, until eventually it hits a number. And the number it hits is exactly 7 grams. Let's make the writing a bit bigger again. It's exactly 7 grams. And I stop and I decide I'm going to count all of the atoms. Now at this stage, I've got this little pile of atoms. Been adding millions and millions and millions, and they've made this little pile. And now the pile is big enough that I can see it because there's enough atoms there that I can see it. So at this point, I'm going to count all of the atoms and find out how many I have. I've stopped at 7 grams, remember. So I count them, 1, 2, 3, and I keep counting, hundreds of thousands, millions. And I find that I've got 6.02 by 10 to the power of 23 atoms. Wait a second. That's Avogadro's number. Why 7 grams? If we go to our periodic table, look at lithium. 7. Sorry, I'm after blocking it out. Lithium has an atomic mass of 7. So that's what this number does, this mass number, atomic mass. The atomic mass tells you the mass of 1 mole, or Avogadro's number, of atoms. So if I have Avogadro's number of atoms of lithium, it will weigh 7 grams. If I took that many atoms of beryllium, Avogadro's number of beryllium, which is next door to here, then it would have a mass of 9 grams. And this is because each beryllium atom is a little bit more massive, a little bit heavier than each lithium atom. So when I have a mole of them, it would weigh 9 grams. If I took this many atoms of magnesium, here's magnesium, then if I had a mole of them, it would have a mass of 24 grams. Again, because each atom of magnesium is bigger and heavier than each atom of lithium or beryllium. Now, this is why I told you that this number is so useful and so important to chemists, because it bridges the gap between atoms which are incredibly tiny, and it allows us to work with masses of atoms. So the rule is that 6.02 by 10 to the power of 23 atoms of any element, and remember, another way of saying this here, 6.02 by 10 to the 23 is 1 mole. So 1 mole, or 6.02 by 10 to the 23 atoms of any element, has the mass, has a mass equal to that element's, keep it a bit tidier, sorry, to that element's atomic mass. That's what we've seen with lithium, beryllium, and magnesium. Let's have a look at the at another example. You're going to see the magic of this number now. Say we take water, H2O. We take water and we put it in a beaker. Take water, we want to put it into a beaker. How much are we putting in? Well, if we think about it for a second, water is made of 3 atoms. It's 2 hydrogens bonded with 1 oxygen atom. So what do I need to know what mass this is going to have? If I'm going to take 1 mole of atoms, 6.02 by 10 to the power of 23, or 1 mole. I'm going to take 1 mole of these molecules, which a molecule is this group of atoms here. So I'm going to take 1 mole of this molecule, and I'm going to add it to the beaker, and I'm going to see it as like a little bit of liquid down at the bottom of the beaker. I'm going to do this on a mass balance so I can find out mass. How much would it weigh? Question mark. How many grams? Okay, well, to answer that question, I need to know, well, what would the formula mass of this substance be? The MO. The MO for this substance is, well, I take my mass of my oxygen, which is 16, plus the mass of each hydrogen, which is 1 each. 16 plus 1 equal to 18. Now, if I take 1 mole of water particles and I put them in a beaker and I find the mass, I will find that it's actually exactly 18 grams. So that is the magic of this number. Now, let's say instead of adding 1 mole, I decided to add 2 moles. So I did it again. I've got H2O, and I've got the same substance again. I've got an O bonded with 2 hydrogen atoms. This, I know that my MO is equal to 18, same as above. And I take my water and I put it into a beaker. But this time, I'm adding 2 moles. 2 moles. Sorry about this now. Video's crashing on me. Just gonna reset this up. 1 second, please. Sorry about that. We should be good to go again. So, where was I? So we take water, and instead of adding 1 mole of water to the mass balance, we're going to add 2 moles of water. I've obviously added more, so there's going to be more water here. But how would that affect the mass? What would my mass be now of 2 moles? Well, I've just added twice the amount of water. So if 1 mole was 18 grams, then 2 moles is going to be twice that mass, going to be 36 grams. And the magic of this is that I can actually turn this into an equation. Because what I've done here to get my mass equals, I've taken my MR, which was 18. So here is my MR, which is 18. And I've multiplied it by the number of moles. And that was 2 moles. So what I really did here to get the mass was I took my MR, 18, and I times it by 2. Give me the mass of 36 grams. Let's do another example. Say, for example, I've got this substance, CO2. This is called carbon dioxide. Carbon dioxide has a carbon atom joined with 2 oxygen atoms. So its MR is going to be 16 plus 16, that's the mass of the 2 oxygens, plus 12 for the carbon. My MR is going to be 44. Now I take some carbon dioxide and I put it in a beaker. The amount that I put in is 4.83 moles. My mass, what will my mass be? What will it read here? Well, I'm not sure yet. I know that 1 mole equals 44 grams. So I take my MR, which is 44, multiply it by the number of moles, which was 1. That gives me 44 grams. That's for 1 mole. Now, if I have 4.83 moles, well then I take my MR, which is 44, and I multiply it by the number of moles, which is 4.83. That gives me, so I'll get my calculator out and I do 44 times 4.83. That gives me 212.52 grams. Okay, so that's given me a formula to work out the number of moles. So it looks like this so far. What I've got is mass equals MR times moles. Take my MR and multiply it by the number of moles I have to get the mass. This actually isn't the way scientists write it. Scientists traditionally write it to find the number of moles. So we've been finding mass, but scientists usually write this equation as if they want to find the number of moles. So to do that, they need to have moles by itself on one side of the equation. And then whenever we have this, what we do is we have to get rid of this term here. We have to get rid of the term that's on the same side as moles. Now we can't just cross it off and pretend it doesn't exist. What we need to do to get rid of a term is we need to divide it by itself, MR, like this. Now when we do this, divide MR by MR. So when we divide anything by itself, it gives us a 1. So if you divide 2 by 2, it gives you 1. If you divide 100 by 100, it gives you 1. If you divide x by x, it gives you 1. Any term divided by itself gives you 1. So that's why we divide it by itself to make it a 1. Then it doesn't affect the equation. But because this is an equal sign, whatever you do on the left-hand side, you must also do on the right-hand side. So if we divide the MR by MR on this side, then we need to divide the mass by the MR on this side. So now we have mole by itself on the left, and we have mass divided by, that sign over means divided by, mass divided by MR. So the actual way scientists would write this equation would be like this. Moles equals mass divided by MR. And this is something you should take down. Okay, so you should pause the video and write that down. I'm going to do some examples using this equation. Now, in my videos, whenever we come across an equation, I use a method to help you work out, and it works for any equation, okay? And it's called a Descu method. Now, if you've watched some of my videos before, you will have seen this before. If not, no problem, I'm going to explain it to you now. Okay. So when we get a problem like this, say we get a problem like this problem here. Sorry, the screen's gone funny on me. Say we want to know how many moles are in 30 grams of CO2. So we have a problem, we want to find it out. We use the Descu method, DESCU. And how this works is we write the letters D, E, S, C, and U down the side. And what these letters stand for, D stands for data. And we find the data that we need in the question. And I will show you how to apply it in a second. I'm just going to tell you what each letter means first. D stands for data. E stands for equation. So what is the equation that I need to use to solve this problem? S stands for substitute. And this means you're going to put in data from your data line into the equation, substitute in numbers instead of letters or words. C stands for calculate. So you get your calculator out and you do the sum. And U stands for units. What are my units? So this is the Descu method. I'm going to show you how to do it now. Don't worry, I'm going to show you a few examples. I'm going to give you time. I'm going to tell you to pause and take it down. Don't be trying to take anything down, because if you're trying to write and listen at the same time, you're not actually going to understand and hear what I'm saying. So listen, you can pause the video after and take it down if you want. All right, so what is my data? Well, I want to know how many moles. That doesn't give me any data. But what I do know is that my mass is 30 grams. So in my question, I know my mass is 30 grams. I know also that the substance is CO2. So I know I can work out my MR. My moles, I don't know, but I do know mass, and I can work out the MR. So the three variables, three things I've got to link here are moles, mass, and MR. On my data line then, I'm going to write down what I know. I know that my mass is equal to 30 grams. So that's my first piece of data. And I know that my MR, this substance is CO2. So I know I can work out my MR. It's going to be 12 for the carbon, plus 16 for the oxygen, and plus 16 for the second oxygen. That gives me a total of 44. Okay. Now, I also know that I'm interested in moles, but I don't know the answer for moles. So that's a question mark. And what's the equation that links all these things together? We just learned about it and we just wrote it down. We learned up here that moles equals mass divided by MR. So moles equals mass divided by MR. The next line is substitute. So what we do here is we substitute, instead of a word in a formula, we're going to put in a number. Well, I know that mass equals 30. So instead of the word mass in the formula, I can put in the number 30 grams. And instead of, I know that MR equals 44. So instead of MR, I can put in the number 44. What that gives me, I can rewrite my equation. Moles, I still don't know moles. So at the moment, my moles stays a word because I have nothing to substitute in, only a question mark. Moles equals 30 divided by 44. It really is this simple. You just put the numbers in instead of the words. Calculate. So you get out your calculator. We get out my calculator now. I'm going to do 30 divided by 44. And that gives me 0.68. Now you're going to get 0.68181818 recurrent. So I'm just going to round it to 0.68. So 2 decimal places here is enough. And my units, what am I finding? Remember, I was finding moles. So I'm just going to say 0.68 moles. So it really is that simple. So what I'm going to do is ask you to pause the video and take this down as an example. How to find moles. Okay, so you should only be listening to my voice again if you took down that example, and how to use the Descu method. Now I'm going to show, we're going to do another example now, don't worry. I'm not going to leave you on your own just yet. I'm going to do another example. So say we have a question, how many moles in 175 grams of Na2CO3? Okay, we're going to use, again, Descu method. So I'm going to write the letters down the side, D, E, S, C, and U. Descu. So my first line, D, means data. What is my data in the equation? Well, I have a mass, I'm going to highlight, I have a mass of 175 grams. This is a mass. I have the formula for a compound, so I know I can work out the MR. And I want to know how many moles. So my moles is a big question mark. So let's fill in the D line, data. D stands for data. So I know my mass equals 175 grams. Notice the way I am doing this I'm going to follow this method, Descu, every time. And again, if I do that, I won't go wrong. But if I stray from this, I would find it, I would lose track of it and I would probably make mistakes. So if you follow this method every time, it works. And the great thing about this method is, if you're talking about any other equation, even in like, if you're doing distance, speed, and time in maths or physics, you can just change the equation. The equation line becomes different and you can still use the same method. So the mass is 175 grams. I also can work out my MR, my formula mass. The substance is Na2CO3. So we learned how to do this in the second video. We've got 23, or in the first video, sorry, plus 23, that's the 2 sodiums, plus 12 for the carbon, and then I've got 3 oxygen, so plus 16, plus 16, plus 16. And that gives me a total, add them up on my calculator, me 106. Now, if you have no idea what I'm doing with the MRs there, then that means you need to go back and watch the video, the first video on MRs. The other thing here is that my moles is what I'm trying to find. It's a question mark. I don't know how many moles. What is my equation? So speak your answer to the screen. What is the equation here? Okay, hopefully you said moles equals mass divided by MR. So the next thing we do is we substitute in the numbers. So my mass, I can put the number 175 in for mass, and I can put the number 106 in for MR. So I'm going to rewrite out the equation. I'm going to get moles equals 175 divided by 106. I'm going to do that on a calculator. 175 divided by 106. Calculate gives me equals 1.65 moles. Sorry, moles is on the next line. 1.65, and then units equals, so my units are 1.65 moles. So my units are moles. That's my final answer. Right, it really is that easy, okay? So hopefully you'll be able to do this one by yourself. So I'm going to give you one to do now, okay? If you want, you'll pause the video and take that example down as well, if you feel like you need a second one. All right, I'm going to give you one to do now. All right, the question here is, how many moles in 250 grams of, let's see, we'll do MgCl2. All right, pause the video, do the problem, and then play for the answer. All right, the first thing you should have done is you should have written Descu down the side, D-E-S-C-U. Now, if you weren't able to get started at all, you had no idea, then I suggest you start by writing Descu down now and then go and have a go at doing the sum. If you're really struggling, you need to go back and watch how I did it again. Now, what is my data line? Well, my data line is that the mass is equal to 250 grams. My MR of MgCl2 is equal to 24 plus 35.5 plus 35.5. I should have maybe explained this one. Because magnesium, or because chlorine is 35.5, we generally tend to leave it as 35.5. We don't round it up or down. So most of the other ones, if they're 30, if it was 35.8, we would round it to 36. But because it's 35.5, we leave it like that. So maybe I should have explained that one first. So I'm going to get you to pause the video. And if you already rounded it, just fix it up now, change it. And that's going to obviously affect the rest of your calculation. So just go back and have a look at it again. Okay, so then you should have written the equation, moles equals mass divided by MR. Well done. That's something we're just going to have to learn that one off by heart. But hopefully, if you understand that relationship from when I explained it, you should be able to just figure it out by thinking about it. Moles then equals, all right, we're going to substitute. So we're going to put in for our mass 250 grams. We can leave off the units for now, actually, 250, and divide it by the MR, which was, actually, I never worked it out up here. This should be calculated. 95. Okay. Yeah, 95. So we're going to put that in here then as MR, 250 divided by 95. Calculate is the next thing to do. Calculate equals 2.63. And then my units, I'm talking about 2.63 moles. That's my final answer. Well done. You can already now get some marks on a Leaving Cert chemistry paper for that. All right, got some more practice questions for you guys to do now. Okay, so let's scroll back up here. And what I'm going to get you guys to do is I'm going to get to pause the video and do the questions, play for the answers. All right. I think you should get on pretty good with these. Okay, I think you should have got on okay. Number 11, you might need a little bit of help with 1 kilogram. Hopefully, you know that 1 kilogram is 1,000 grams. Okay, so if you didn't know that, then you need to maybe go and have another look at it. 1,000 grams. And also number 12, we've got 1.2 kilograms, which is 1,200 grams. So So again, that might have been one that might have tripped you up. So just double check now that you do have them in grams and go and have another go at them if you didn't. Also, number 10, don't forget that if it's in brackets, to work out the MR, you have to multiply everything inside the brackets by the number after the brackets. Okay, that's the only thing I could see catching you up there. So again, if you haven't already done number 1 to 12, if you don't try these questions, guys, you ain't going to learn. And if you do, you're going to learn and it's going to stick with you, I promise. Okay. All right. So here are the answers. Pause the video and correct your answers now. If you're getting a lot of these wrong, guys, then there's some little problem somewhere. You need to go back and watch my method again, how I did it. Make sure you're doing it exactly the same way. Do drop me a comment down below if there's something that's not working out, if it's not working for you, and maybe I can do another video to explain what I think is going wrong. If you found the video easy enough to follow, do leave us a like and maybe subscribe to the channel for more videos, and I'll see you in the next one.